Pre-calc, welcome to 7.5, the sum and difference formulas. Hey guys, there are some extensive proofs of the sum and difference formulas. If you're interested in these, they're available to you on Khan Academy. I'm not going to take the 10 minutes to do the proof here on this video. But if you want to look it up as to why this is the way that it is, that is on Khan Academy. Just Google the sum and difference formulas and it'll come up with some proofs. But anyway, let's get into this. For today, what I'm going to have you do is just memorize the sum and difference formulas. So you need to have those memorized for your test, okay? So you got to really take some time to memorize these. And some objectives for the day, we're going to use the sum and difference formula to find exact values, to establish identities. Then we're going to use them involving inverse trig functions, and then solve trig equations linear in sine and cosine. Okay, so theorem 1. This is the first thing you need to have memorized. Okay, so really what a sum and difference formula is it's saying, okay, if I take the cosine of alpha plus beta, that's two separate angles. Okay, so if I'm adding two angles together and I want to know the cosine of the two angles added together, the way that you find it is, and I want to just highlight how this works. For cosine, it's very different than sine, okay? So, well, not very different, but quite a bit different. Cosine is always cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Okay, if you are finding the sum of two angles, you're going to multiply the cosine of each individual angle together and then subtract. So notice this, the signs here are opposite. The signs multiplied together. If you want to know the difference between two, so if you take two angles and you subtract the two and you want to know the cosine of those, you're going to multiply the cosines together and then add the sines. Okay, and again, there are proofs, extensive proofs of why we do this available out there that I encourage you to check out if you're curious. But otherwise, just memorize this thing. Okay, so cosine, cosine, sine, sine with the opposite sign. Okay, so for example 1, it says, using the sum formula, find an exact value of cosine of 105 degrees. Okay, so what they want us to do is to break this up into two pieces. Okay, so let's look for two nice pieces. By the way, the nice angles that we know, just to review, 30 degrees, 45 degrees, and 60 degrees, and obviously any kind of 90 degree angle, we know sines and cosines at those particular places. So I'm going to try to break it up into two of those. So here, 105, that I think 60 and 45 give me that. So I can say this is the same thing as the cosine of 60 degrees plus 45 degrees. Okay, so now what I'm going to do is I'm going to use my sum formula, which tells me that the cosine of 60 times the cosine of 45 minus, because it's the opposite sign, the sine of 60, the cosine of 45. Okay, now remember it's alpha, cosine of alpha, cosine of beta, cosine of alpha, sine beta, so the pattern stays the same. In the other one it does not. Okay, so what is the cosine evaluated at 60 degrees? Well, at 60 degrees, the cosine there, the x value at 60 degrees, if you'll remember, is 1/2. Okay, the cosine at 45 degrees, that's the square root of 2 over 2. And then we're going to take that and subtract the sine at 60 degrees. The sine at 60 degrees is square root of 3 over 2. And the cosine at 45, oh sorry, that should say sine, not cosine. My apologies. Okay, sine, sorry if you're confused there. Sine of 45 degrees is square root of 2 over 2. Okay, so now when I simplify this, this comes out to the square root of 2 over 4 minus the square root of 6 over 4. They might have you leave it like this. If they want you to take the fraction out of there, I could take a fourth out of here and I'd be left with 1/4 times the square root of 2 minus the square root of 6. Either way is probably okay. But that's how I would find the exact value of the cosine of 105 degrees. Okay, don't put it in your calculator and get a decimal. They want this. Or this. I think either way would be fine. Okay. Let's make sure we did that right. Yep, 1/4 times the square root of 2 minus 6. Perfect. Okay, so example 2 says, using the difference formula now, find an exact value of the cosine of 5 pi over 12. So they want us to use a difference formula. Okay, so just a reminder that the cosine for a difference formula would be the exact same thing. It's going to be whatever this. Let's break this into two pieces that are easy. Easiest pieces for 12ths. Let's see here. We could do, well, 5 pi over 12. That's not a very nice number. So to get to that same place, I do like 6 pi over 12 because that would give me just pi over 2. The other thing that I could do here is I could treat this as, man, I don't know that I would even go here with the difference formula. Let's do this a little bit smarter. We know angles for pi over 6. We know angles for pi over 3. And we know angles for pi over 2. And we know angles for pi over 4. Right, so pi over 6 is 30 degrees, pi over 3 is 60 degrees, pi over 2 is 90 degrees, pi over 4 is 45 degrees. Okay, so can we get this into two pieces that are from those 4 examples there? And I think we can. If we did 2 pi over 12, that's equal to pi over 6. And if I did 3 pi over 12, that's equal to pi over 4. So I'm going to treat this as the same thing as 2 pi over 12 plus, I'm not going to use a difference, I'm going to use the sum formula, plus 3 pi over 12. Okay, which again, those simplify, right? So that's the same thing as the cosine of pi over 6 plus pi over 4. Which is 30 degrees and 45 degrees if we need that. Okay, so let's do this. Let's just use our sum formula again. Okay, so to do this, we get the cosine of pi over 6 times the cosine of pi over 4 minus the sine of pi over 6 times the sine of pi over 4. Okay, the cosine of pi over 6, that's 30 degrees. The cosine there is the square root of 3 over 2 times the cosine of pi over 4, which is square root of 2 over 2, minus the sine at pi over 6, which is 1/2, times the sine at pi over 4, which is square root of 2 over 2. Okay, so when I do this out, I get square root of 6 over 4 minus, this will be the square root of 2 over 4, which is equal to 1/4 the square root of 6 minus the square root of 2. Hey, don't try to subtract these two things. The only other way that you could write this is the square root of 6 minus the square root of 2 over 4. Right? That's okay, but don't try to subtract these and say that this is the same thing as the square root of 4 because it is not. You have to have like terms. Okay, so any of these answers should work for the exact value of cosine of 5 pi over 12. And they used the 1/4. Okay, so they might want it like this, but I don't think it matters that much. Okay, a couple more identities, you guys. Remember that sine and cosine are opposites of each other, right? So for cosine, we know that the sine of any theta is equal to the cosine evaluated at 90 minus that theta. Okay, so if you take pi over 2 and subtract your theta, you can get the cosine. Or sine, and vice versa, right? These sine and cosine are opposites of each other. So just know that you can always get there by taking 90 degrees and subtracting your theta. You'll get the opposite function. Okay. let's continue with this theorem now. This is your sine sum and difference formula, which again, you must memorize this, you guys. You must memorize this. If you memorize one, you kind of have them both. For sine, things are the same sign. Okay, so it's for sine, it's sine, cosine, cosine, sine. So the cosines are on the inside, the sines are on the outside, and then notice it goes alpha, beta, alpha, beta. Okay? Alpha, beta, alpha, beta. So that kind of stays the same with both. So say we have the sine of 45 degrees plus 30 degrees. Okay, so what that would end up being is sine of 45 cosine of 30 minus cosine of 45 sine of 30. Okay. So if it helps you to label this as alpha and beta, you are welcome to do that. Okay, so and oh, sorry, this is plus. If I'm doing this one, it's plus. So the signs stay the same on the sine sum and difference formulas. On the cosines, the signs change. All right. So I know it's a lot to remember, but definitely take some time to memorize that. Okay, so for example 3, we're going to use the difference formula to find an exact value. So now we'll use a difference formula because they have sine of pi over 12. So the sine of pi over 12 can be, again, we want things that are equivalent to the things that we like. So for that one, we could say, well, 3 pi, well, here's what they used. I guess we can use that. So 3 pi over 12 is the same thing as pi over 4. So we like that. We're going to use that. And then we know that 2 pi over 12 is equal to pi over 6, which we like. And if we subtract those two, we get the pi over 12. So here's what we're going to do. We are going to go ahead and jump right into our difference formula for sine. So remember that for sine, the sign stays the same, right? So for sine, again, it's sine, cosine, cosine, sine. Okay, so let's break this up. Let's write this as sine of pi over 4 minus pi over 6. Okay, and let's go ahead. This is alpha, this is beta. So let's do sine of pi over 4, cosine of pi over 6. Okay, minus, because we're doing a difference formula and the sign stays the same, cosine of pi over 4, sine of pi over 6. Okay, when we plug those things in, the sine of pi over 4 is the square root of 2 over 2. The cosine of pi over 6 is equal to the square root of 3 over 2. We're going to subtract the cosine of pi over 4, which is square root of 2 over 2, times the sine of pi over 6, which is a half. When we do this, we get the square root of 6 over 4 minus the square root of 2 over 4, which is the same thing as what we had before, which is 1/4 times the square root of 6 minus square root of 2. Which I think is what we had when we did it up here somewhere. Oh well. Okay. Example 4, using the sum formula to find an exact value. Okay, so here, notice this is sine, cosine, cosine, sine with an addition sign in between here. So this is the same thing. So we got to identify, since it's sine, cosine, cosine, sine, this is a sine of two angles. The two angles are, in its addition, 75 plus 15, which is equal to the sine of 90 degrees. The sine at 90 degrees is equal to 1. So the answer to that is 1.